Oh, good morning, Michaela. How are you? Oh, nasan yung dalawa?
Morning po.
Morning. Where the two? Sige, tuloy na tayo. We will use the same platform. We will not leave this broadcast anymore as we continue later on your calculus 3. Is that part of your, what subject is that? Yung ano ba yan? Sinasabi mo, yung micro-teach ba yan?
Ano sir? Teaching mathematics po.
Okay. Sige, good. Sige, okay lang. Buti sinabi mo so that we could squeeze
Sige po.
Okay. Tuloy na tayo muna sa 140. Konti na lang yung slide na to, no? I don't know where to. So actually, ano na lang to. This is more of a summary already. Okay, I'm getting this from Professor Reyes of Mapua. This lecture notes. Now we already discussed this one regarding the fifth postulate that would differentiate Euclidean. By the way, let's open our prayer first. Father in heaven, we thank you for this day. Thank you for the opportunity where we could continue our discussion on 143. This is our culminating day for lecture, and next week will be our fellowship week. Lord, I pray for your mercy and grace to sustain us, and also for the students for their preparation for their respective courses, final exam, and performance-based test. I pray for your mercy and grace. This is our prayer in Christ's name. All right, so far we have already discussed this, no? As a matter of summary, that Euclidean and non-Euclidean differs on the fifth postulate. So basically, if a transversal falls in two lines in such a way that the interior angles of one side of the transversal are less than the two right angles, now then the lines meet on that side on which the angles are less than two right angles. Meaning the interior angles, if their sum is not too equivalent to 90 degrees or 180 degrees, meaning they're not parallel, yung ibig sabihin, they will intersect on the side of which angle is less than 180. So para siya may kailan na trapezoid. So imagine a trapezoid. No, a trapezoid that is not parallel on the base. For in this one is larger than 180. Ultimately, the one that will have less 180 as far as interior angle is concerned will have this point of intersection for those two lines. So that is how we refer to the parallel postulate of Euclid, and it differs, no, as we look at spherical or hyperbolic or even the projective geometry. So they are differing. Okay, according to Euclid, no, so angles A, B, and B meet. If the sum of the measures of B, A, B, and angle ABC is less than pi agents. So meaning D, A, B, and A, B, C. So meaning these are interior angles. Okay, ready na these are actually some of the interior angles. Can you visualize, Mikaela? Interior angle is D, A, B, and C, D, A, or ABC. So interior angles. So when there's sums less than pi or less than 180 degrees, okay, that becomes intersected on the side that is on which is less. Of course, on the opposite side, we could see that this is larger than 180. Okay, makes sense, Mikaela? So the side that it will intersect is on the side that if the interior angles is less than 180. Okay, that's one way of expressing the parallel postulate. No, the word parallel does not appear in the fifth postulate. So the original wordings of Euclid does not say parallel. Actually, it's just a modern equivalency of the fifth postulate. Okay, so yung natin dyan. Now the wording of Euclid's fifth postulate that is most commonly used what we call play pairs action. So play pairs to a point that on a given line exactly one line can be drawn in the plane parallel to the given line. That's pair place action. That's the pair place equivalent of the fifth postulate of Euclid. Right? Here, the word parallel means not intersecting or having no Euclidean points in common. Okay, so that's the idea of parallel. In fact, we could reflect that into our coordinate system. So that is very useful, this concept. Ayan, no? Yung chat ni Gillian. Okay, anyway, so I'll be quick with this, then we will move to our discussion in calculus 3 afterwards. So maabutan nila calculus 3 na siguro. Okay, so the word parallel means that intersecting or no Euclidean point in common, pair place axiom, and the original postulate are logically equivalent. Equivalent. From the time Euclid stated his postulates about 300 BC, mathematician attempted to show that the postulate was actually a theorem that could be proved approved from other postulates. None of these people succeed. So none of them make use of the first core postulate to prove the fifth postulate. Okay? And shortly after 1800, mathematicians called such as Carl Friedrich Gauss began to realize that the fifth postulate could never be proved from others because it was indeed independent postulate. Welcome, Isa. How are you? So kasado na tayo next week, guys. 9 a.m. 9 a.m. There at around 9 a.m. At our room. Yan. Together with the third year in the freshman. No? I hope I would have some time fellowship, good time fellowship with God's word. I'm already preparing my short message challenge. Perhaps you will be challenged. No? And then we'll have our last lunch fellowship together. The person only. Mikaela, by the way, sino pwede magpakanta sa mga boys? At sabihin lang. Si Gian siguro, no? Kapit Mikaela. Di ba pwede magpakanta? One hymn would be enough perhaps.
Ano naman kasi?
Sino? Si Gian, no? Pwede, no? Okay. Sige. Just ask Gian, no? To at least one hymn. Yan lang naman. Okay na yan. The preparation for the teaching. Alright. So anyway. Okay, Hazel, how about you? How are you? Busy pa rin ba, Hazel? Ayan, so parang si Gillian abala. So last time, yung kanyang mother was sent out to Uganda. I think now there's her church actually have a fellowship. So, yan, nasa side si Gillian. Alright. DC. Okay. Pareho tayong DC. So, wala. By the way, anytime within this week, also just for this course 143, I'll just wait for your final project to be submitted. That's number 1. And then number 2, your final multiple choice. So I get to create a folder for the multiple choice. And then so far yun na lang naman. And then yung mga summaries, yung suppose na-upload yun yung mga summary outline natin. So that's it already. And then just focus on the final project and submit multiple choice. So that will be for the requirement for 143. Okay? Yun yung ating doon. So, Agos realized that this is an independent postulate in the set of Euclidean post, not a theorem. So it's an independent postulate. The first account of non-Euclidean geometry is published, no? On the assumption that through a point not given a line more than one line can be drawn parallel to a given plane. Okay? So there's 2 or more parallel. Now that is probable possible in what we call hyperbolic geometry. Was discovered independently by a Russian Nikolai Lobachevsky, and all about the same time a Hungarian Janos Bolyai. No? That's why they are called on this name, no? Lobachevsky Bolyai geometry. So yun yung, but also known as hyperbolic geometry. Alright? So guys, pag tandaan nyo rin yung concept kasi lumalabas din yung mga concepts ito lumalabas sa board exam. Yan, yung mga term na yan. Nikolai Lobachevsky and Janos Bolyai. That's why Lobachevsky Bolyai geometry is also known as hyperbolic geometry. The results were published in 1830. A second type of non-Euclidean elliptic is introduced briefly, no, as well. Now, three possible notions for parallelism at the contested postulate of Euclid or Euclidean. There's only one line parallel to the given line through point P. For elliptical or spherical, given a line, no? So for there is no parallel line to line P to point P. For a while, guys, I need to check my audio. Okay, for a while, guys, kasi nung rin-record ko, nagkakaproblema, no? May mga bis along the way, yung aking ano. There are glitches. Okay, for a while, guys, no, I need to Alright. So for hyperbolic, there are infinite lines parallel to L through P. Infinite numbers naman, no? So that's possible only for a hyperbolic plane. No, but for elliptical spherical, since we are using an ellipse or sphere, all lines will be intersecting in a particular point of a sphere. So kaya walang parallel lines because all are intersecting for elliptical, no? Alright, for hyperbolic, there is infinite lines, okay? So just take note of this. I know we already made this as part of your activity before, no? So the differences of the three. All right. Okay, acknowledging Ens Jaire is watching us from our Facebook live stream. Welcome. Ens Jaire is watching us. All right. Thank you, Ens Jaire, for Facebook live stream. No? So we're live on our Facebook, our Baptist Ministerial Seminary page, and YouTube channel, CBC Ministries online page. All right. So this is the possible notions for parallelism. So for Euclidean, so only one line. No? For elliptical, no parallel lines at all. Everyone will intersect at particular point. No? At a particular point, it will intersect. And for hyperbolic, there are infinite number of parallel lines, right? So that's the idea for hyperbolic. Okay, another difference that the lines remain at a constant distance from each other and are parallel. For hyperbolic, there are lines are curved away. So that's when we are looking into a hyperbolic plane for each other and increase in distance as one moves further from the points of intersection, but with a common perpendicular and ultra parallels. So yun yung normally yung paraboloid, no? Ay hyperboloid. Have you seen a hyperboloid? Gawin yung 3D yung ano, no? Yung 3D image ng isang hyperbola. So ganun ang hyperbolic plane. Yung solid niya nasa labas, yung loob niya vacuum. Yun ang pagkakaiba niya sa spherical. Yung spherical naman, yung buo yung sa loob, then vacuum sa labas. Sa hyperbolic, yung nasa loob ang vacuum. And then yung solid niya nasa labas. Okay? So the lines of the curve toward each other eventually intersect with each other. So there's no parallel lines for elliptic. So ang hyperbolic curve away. So meaning it won't intersect, therefore parallel. Alright? So I hope just like this one. So Euclidean, no, perfect siya. For hyperbolic, there are lines or family of lines that are towards away, curve away, and they will not intersect. Okay? And then for elliptic, everyone will intersect at a particular point. They're curve towards, no? Or curve toward na tinatawag. Okay? So this is an illustration for that. And then another is that Euclidean, the sum of the triangle, we know this already. It's just a matter of review. That a triangle in Euclidean is 180. Hyperbolic, it's less than 180. And elliptic, as you could see, the spherical triangle is always greater than 180. Okay, you try to triangulate a location in a globe and you create a spherical triangle, a spherical triangle wherein the triangle is greater than 180 degrees. So geometry in a sphere with greater circles, right? So 180, it's greater than. So these are examples, no? I suppose you're familiar with this. So for sphere, these are the spherical triangles. The sum of the interior angles is definitely greater than 180 Euclidean. It's just like a triangle here, and your hyperbolic space. This is the hyperboloid that I'm mentioning to you, wherein the vacuum is on the center, and on the outermost is the solid part. So the tendency for a triangle is to shrink such that it will be less 180 degrees as far as the interior angles is concerned, right? Okay, there's other representation. I suppose some of you have created a slide similar to this. No? So these are for a plane like Euclidean, it's a zero curvature, meaning it's flat, basically flat. Now for a positive curvature, we have the elliptic geometry. So meaning, eventually, you will not see the object from the curve. Just like the sphere that we are into, the Earth is a spherical spheroid, elliptical spheroid, wherein it's a flattened sphere. In a particular distance of time or distance time difference, you cannot see anymore the object. That is actually perhaps walking away or flying away or driving away from your reference point. So meaning it's vanishing. That's the positive curvature, meaning there's a positive curvature. when for the case of hyperbolic, it's negative. Now you cannot fail to see, to have a line of sight of under negative curvature. Kasi sa negative curvature, pag ano naman, excuse me, pag ano na lang guys, so makikita mo, habang lumalayo ka, nakikita mo pa rin. Samantalang yung sphere, yung sa atin, habang lumalayo, lalong nawawala. Okay, that's the negative curvature. Question, clarification, guys. Right? So next to this, we could have the characteristic of postulate through a given point C and not given at AB. Ito yon. Passes one or more, passes more than one line in a plane not intersecting given line. So this would be, but this, basically, they are curving away. Now that's the property of this line. Though you have a common point C here, basically they're curving away. Now because you are in a hyperbolic plane, it will not intersect line AB, no, at all, because the curve, the line is curving away line AB. Now though they are too deep, in fact infinite number of lines, you could do that because basically they're curving away. So that's the property of, ayan, so it assumes CD and CE, all right, are two distinct lines through C that is neither intersect AB. So that's possible only in a hyperbolic plane. All right. So in fact, this is more of a three-dimension. In a way, there's a sort of a 3D here. Now, theorem, though through a given point C, not given to line AB, passes an infinite number of lines not intersecting to the given line. All right. So you could see, you could have a three-dimensional look here, wherein you could put all of the lines that will intersect C, but will not pass through AB. Okay, guys, make sense? I hope this is a clearer view. Okay, guys, wait lang ha. May mga phone-in questions lang tayo. Actually, yan. All right, so yeah, we're continuing. Make sense ba guys? This illustration, this is more of how our hyperbolic plane works, no? So there are infinite numbers of line segment intersecting at point C, but will never intersect AB. All right. Okay. So here lines through a given point P and asymptotic to line R. Yan, asymptote. So ibig sabihin, it will never reach R. Asymptote. You know asymptote guys, no? So yung asymptotical line, hindi niya matatouch yun. No? Therefore, it won't intersect. So that's another, either it curve away or it's an asymptotical line. Just like a hyperbola guys in itself. A hyperbola has an asymptote line, right? Alright, guys? You still recall the asymptote of a hyperbola? The asymptote is just guiding the hyperbola, but the hyperbola per se will not intersect the asymptotical line. This could be applied now here in this fifth postulate. No? Okay. Now, for elliptic geometry, it's the mathematician Bernard Riemann suggests a geometry now called elliptic based on the alternative to the fifth postulate, which states that there is no parallels to the line through a point on a line. So characteristic, Hazel went away for a while. Yan. Any two lines na sabi dito in a plane meet at an ordinary point. So that's for elliptic geometry because they are circumnavigating. The lines are circumnavigating to the sphere. Therefore, at a certain point, they will intersect. No, they will intersect. No, the baseline and the supposed line drawn at point P. Right? So at any point, at a particular point in that plane, they will intersect. Okay, so that's basically a football, no? So we're in an ellipse could intersect at a particular point. So if the figure is elliptic geometry, EH and FI both perpendicular to CG, these two lines meet at a point A because of the characteristic postulate that any two lines intersect. All right? Just imagine your latitude, Michaela. The latitude in a flat map does not intersect. But if you will put it in a globe, that's the reality. The globe intersect at, Michaela, yung latitude. Pag tinignan mo yung globo, saan mag-i-intersect yung mga latitudes ng mapa na nasa globo?
Sa taas, sa baba.
Anong tawag doon? May tawag doon North Pole and South Pole, yes, they will intersect there. All of the latitudes will intersect at North and South Pole. So that is elliptic. So though they are parallel, no, with respect to the equator, they will still intersect at either both North and South Pole. Okay, so that is elliptical or spherical geometry. Okay. So in elliptic, no, it's customary to use curves to show the straight lines. Yes, no. Lalo na yung mapa, when converted to a globe, that becomes a curve. And the curve will always intersect at a particular point. Right? One type of geometry that could be overlapped with elliptic spherical. No? That's why sometimes they are interchangeable. No? Spherical geometry, there is no parallel line since any two lines must intersect also. As far as a model of a sphere and a model of an ellipsoid, so basically they're the same. However, unlike spherical geometry, two lines are usually assumed to intersect at a single point rather than two in elliptic geometry. Yun yung kaibahan niya. No? So, rather two. That's one point. So because of this, the elliptic geometry is sometimes referred to single elliptic. Okay, at least we know, no? And single elliptic, whereas spherical is sometimes called the double elliptic. No, because the points of intersection is two. No, 2 points of intersection. No, for your spherical geometry, and the elliptic geometry is assumed to be one single point only. Okay, so that's the difference. Now, the main difference between spherical and Euclidean is that instead of describing a plane at a flat, no, a plane is a sphere. No? So doon nagkakatalo doon sa no. So yan, that's really crazy according to Euclid. No? But in reality, it's not crazy. That's the reality. No, we are standing on a sphere, and we thought that's just a flat. No, but it's not flat. It's basically curved, no, of a sphere. All right. A line that is a great circle is a sphere on a sphere. And a great circle is any circle on a sphere that has the same center as the sphere. All right. So perhaps the equator and perhaps this prime meridian here. So these are the great great circles. Right. Points are exactly the same, just on the sphere. Something like that. So it always intersect at 2 points, that great circle. No? So for instance, prime meridian and the equator would meet at 2 points exactly. So 2 points exactly in a sphere. Okay, the question is that are Euclid's postulate true in spherical geometry? Let's try the first postulate. Through any 2 points, there is exactly one line. Okay, true. No, on a sphere, no. So there are exactly one line. Through any 3 points, not on the same line, there is exactly one plane. Okay, can we have that? And also true. According to Euclid. Siyempre. Kasi doon makakabuo ka ng spherical triangle doon. Eh. Are Euclid's postulate true? Okay. The third one, a line contains at least 2 points. I think that's basically true. Also in spherical geometry. All right angles are congruent. Yes. So, but not necessarily equal to 90 degrees. No? No? Because there are right triangles that or right angle that are, no, by definition. No? By definition. No? Kasi we won't violate that. No? But triangles could be more than 180. Okay? Okay, so that's the, no, I think Euclid had been insulted here. No? Is the parallel postulate true in spherical geometry? No, that's the problem, the dilemma. Now, given a line a point, not on that line, how many lines can be drawn through the point? Okay, so again, none. Now, therefore, a parallel postulate is false on spherical geometry. So it will somehow intersect at one point in a plane. No, so there is no parallel lines here. So that's the dilemma for fifth postulate. Now it's true for the first four postulate and it's false on the fifth postulate. So really Euclid is gonna be weird on here, no? One mistake, except for the circle in the middle, these horizontal circles do not share a center with a sphere and therefore cannot be considered as parallel lines, even though they appear parallel. Okay, so yung horizontal circles are not actually sharing the same center. Okay, so unlike yung mga vertical lines, yes, because they're forming a great circle. But the horizontal lines are not great circles, meaning the radius is decreasing until it reaches the north and south pole. No? So it's not a great circle. That's a common mistake. Another strange thing happened to spherical is that line is always intersect at 2 points, not 1. Okay, so that's the weird thing for any line on a sphere. It always intersect at 2 points. Okay, that's crazy according to Euclid. The diagram B is between A and C, but A is between B and C as well. No? So even in terms of the betweenness, now below B is between A and C. B is between A and C, but A is also between B and C. Okay, so the issue of betweenness is also sometimes may not be realized here on a spherical plane, only on a flat surface. And also C is between A and B. Nagkagulo na yung betweenness, no? So unlike the line, there is if B is between A and C, no, that's it. B is between C or A. No? But they cannot exchange roles. Unlike here, they could rotate betweenness, no? Or a sphere. No? Okay. Another strange triangle don't have to add to 180 degrees. In the diagram below, triangle ABC has 3 right triangles which add up to 270. Okay. So why it is right? Because it's perpendicular here and it's perpendicular here also. But when they meet on point B, they're also perpendicular. So meaning if it's perpendicular, 90 plus 90 plus 90, 270. So that's very weird for a spherical geometry. So of course, Euclid, you're true only in a flat surface, but not on a spherical, uh, uh, the spherical realm, no? So that's not true. If a spherical geometry is so strange, why do we even start studying it? That's a big question. Because the Earth is a sphere, basically. Okay, it's not flat. It has the characteristic of a sphere. So therefore, we need to learn on spherical geometry as well. No, but of course, the belief of Euclid it's flat, and we know through science that we realize, in fact, the circumnavigation of the Earth have done before. Euclidean geometry cannot use the model of Earth because it is a sphere, right? Instead, the Cartesian coordinates use Euclidean geometry. Longitude and latitude are used as to define the positions of points on the Earth. Yan. Lines and longitude are great. Lines of longitude are great circles running between North and South Pole. Okay. So the center of longitude is called the prime meridian. Yan, prime meridian, right? Longitude is measured in degrees east or west from prime meridian. All right. So I think you know this already. And latitude is the latitude. So center latitude is called the equator. So there are horizontals. Lines of latitude are parallel horizontal circles but not great circles. No? So basically, when pag great circle, hindi siya magpa-parallel. No, kasi they are of degrading radius, no? And different centers. Okay? So it may not be applied to this. No? So latitudes measured in degrees north and south, of course. So those are some real application. Any location on Earth can be found with its latitude and longitude, or sometimes we call it coordinates. Right? So there's coordinate. Tanda mo pa, Micaela, yung coordinate ng Pilipinas? At least the latitude. Yan, tinuro yan sa ating history or geography. No? Yung latitude. Okay, so it's between 4 to 21. Correct me if I'm wrong. No? 4 to 21 degree north latitude. So we're still on the north, but almost already on the equator. No? So 4 degrees. Yung pinaka-south natin, 4 degrees. Yung malapit sa Taiwan, is I think 21. If my memory is correct. Okay? So these are another applications. We have the longitude. Okay, some that becomes a curve here. No? When plotted in a globe. Latitude, no? So we have here, no? So parallel. This picture shows the angle that defines the degrees for latitude and longitude. All right, so we have here this one. No? So with respect to the center, equator, or the Greenwich meridian. The Greenwich meridian is the Greenwich on the other side, meridian on the other side. No? So it will form Greenwich meridian. All right, so the angle here, okay, the latitude point here is the A degrees north and longitude B degrees west. No? So that's how it works. No? Astronomers use a similar concept to define position of stars and objects in the sky. Just like this one. Okay, so zodiac sign, something like that. Okay, so I think that's it for our 143. Fortunately, Aisel is not around, so we will continue with Calculus 3. So that concludes. So my final requirement, Micaela, just tell your classmate, is your project and your multiple choice. So that's the remaining requirement for me. No? So it will be submitted next week or until next week. All right. So you could submit it earlier if you want. But for Calculus 3, I will still have your exams. But this one are take-home exams. No? Basically, these are problem solving, no? Computational, because I could allow you to open resources for this. Okay? So, okay. Let's move on, Micaela. For our Calculus 3. So, pagbalik ni ACL, Calculus 3 na. No, wala na tayong worksheet. We don't do that anymore. Alright? So, okay, let me keep my calculus. Today, a very special day because we will be dealing with differential equations. Differential equations. Have you read the material, Micaela, about the equations? Have you read? So there are, can you recall the methods of solution? One or two methods only, Micaela, before we start, while I'm still preparing my notes here. Uh, 163, 670. Okay. Sharing this also to our chat box.
Sir, okay lang po, sir. Yung link po sa ano po, sa messenger po.
Messenger?
Phone lang po ako sa Google Meet.
Okay. Sige. Sa ano na lang. Messenger. Sige. Pero
Hindi po kasi siya ma-access po sa ano po.
mahirap ma-access. Okay. Saka pag nawala tayo, wala na, no? Sige. I will open my Facebook for that. Okay. Sige, itong file na to, i-share ko muna sa ano.
Okay po.
Sige. By the way, siguro I will specific topics, no? Magdi-deal ako dun sa take home natin sa multiple integration and introduction to differential equation. Teka, I still looking for our chat box here on Facebook. Normally, I close my Facebook when I broadcast. Okay, so here. Okay. Lalagyan ko 4163 only. Okay, tell me if you have access already. Ayan, I think I got your icon here. Yung hindi pa auto view equation dito. So week 17. Wala na si Hazel, nangyari?
Ako po nawala ng signal, sir.
Oo nga eh.
Papunta po kasi siya dito sa Makati.
Really? Papunta siya. So ikaw rin na papunta kang LD?
Nasa biyahe po.
Nasa LD ka?
Nandito na po. Nandito na po.
Okay. So ako lang palang wala dyan. So anyway, yun naman, as planned, next week na. Next week para medyo ano. Okay, what comes in your mind when you see the word differential equations, Micaela? What comes in your mind?
Yung ano lang po siya. Differential calculus lang po.
Okay?
Hindi
Actually,
po familia.
sige. Actually, these are equations of differentials. So, linear equation is just linear variables, x and y. For differential equation is an equation of differentials. Okay, what will make a differential, no? Okay, so I will explain before we have the methods. Okay. So basically, when we are solving differential calculus, so we have this is a derivative, di ba? Okay, say a derivative would be equal to 3x squared, something like that, 3x squared. But when you transpose the differential x and equate it to 0, what would happen? So you're actually creating a differential equation out of this. Oops, wala. So out of this given, so we could say that dy is equal to what? 3x squared dx. And that's an example of a differential equation. These are equations of differentials. Or, pwede rin naman, or it could be 3x squared dx minus dy is equal to 0. Oh, nawala na naman. Perhaps I could write here on the other side, no? Or, so we could say that 3x squared dy is equal to 0. So example, Micaela, of a differential equation. And sometimes we need to solve for the variables. And solving for variables, now, we will look into different methodologies on how to solve this. Okay, because the differential equations has a varied application. And you will make use both integration, mostly integration, that's why it needed to be discussed here, no, because we're done with multiple integration. No? So as for us to answer a particular solution, no? So we have a particular solution or what you call that? A particular solution, no? On a varied values of x and y, or a general solution. So it could be a general solution if there is no parameters, no? Or it could be a particular solution. No? From a general solution, then you have a specific condition, then you could solve for a particular solution out of a general solution. Okay? So it sounds weird, but let me pull down some example problems here. So I suppose you have browsed through already your material. In fact, this is the first time that I will teach this, no, in Calculus 3. And these are examples. And there are methodologies how to solve that. In fact, this is actually just as first order. No, this is an example of first order differential equation. So we will look at the degree of the derivative rather than the number itself. So this is an example of first degree. For instance, I would like to create another one. So this time, I'll be creating a right here, a minus perhaps, so dy, dx, or perhaps there is a constant here, say 2, and then plus 3y, then minus 7 is equal to 0. So this is actually a second degree, no? Second degree. An example of a second degree because the highest differential is equal to 2. Alright? So that's how we will categorize a differential equations. No? Now, there are two concepts here that we need to understand. First and foremost is the order or the degree. The order, so this order or degree are interchangeable. Order of a differential equation is the order of the derivative of highest appearing in it. Like for an example, so both differentials are in first degree, therefore they're of the first degree or order. Okay, so these are interchangeable terms. And then the second example that we have, it's basically obviously second order or second degree differential equation. So that's order. And then also we have solution. So these are the concept. The solution of a differential equation is a function y that satisfies the equation. So for instance, from here we would like to solve for y. Here we would like to solve for y. We could do that. No? We will have a particular solution or a general solution. So solution has two categories, namely, so we have general solution or a specific solution or a particular solution. I think particular solution sounds theological, no? Particular solution. So those are with with no parameters given, we could solve for the general solution. But for specific values of variables x and y, we could solve for a particular solution. Okay. Now, these are the methodologies where we could solve differential equation. Okay. First and foremost, okay, we have as variable separable. No? Meaning, later on, I'll be explaining this. Variable separable meaning you could separate the variables, combine the differential with its variable, and perform the integration process. So that is variable separable DE or differential equations. Okay. Secondly, so we could have homogeneous equation. Homogeneous, homogeneous differential equation. Okay, I'll be defining also. When you say homogeneous, meaning uh, they are of the same ano no. When you say homo, of the same order, of the same order. No? They have the same order. All right. Later I'll be explaining that in detail, no? But just to enumerate, no? Then we have the integrating factors as another method. We need to have some integrating factors, not just like your process of integration, you have integrating factors to be added so that you could perform the indicated operation or integrating factors. And then also there's our methodology for second order equation or second degree. Second order DE. Right? So these are the types of equation that we have. Okay, question before we be specific here, Michaela, have clarification. So basically, we have four methodologies. Methodology for variable separable, and then homogeneous, and then linear order one, and of course, integrating factors, or second order differential, and then integrating factors. So those are the methodologies here, no? And we would like to use some example here. Okay, we're able to read the material, Michaela, so that I will not choose anymore the solved problems. I will jump to the supplementary. Nabasa mo na ba? Or at least browse the material?
Scan lang. Pero
I-scan.
hindi ko siya ganun
Sige.
maintindihan masyado.
Hindi ko na i-skip ko na yung solved problems para kasi ang purpose talaga ng solved problems for reading. But I will demonstrate based on the supplementary problems siguro. Doon na ako kasi ito pwede mo nang basahin yung mga solved problems. So but for supplementary, yan. Okay, so okay, let me ano no. Let me choose some problem here. Okay, I'll just would like to check my audio. Okay, sound check 1, 2 for the broadcast. Okay, sound check 1, 2 for Alright, so I think it's okay pa rin yung audio ko. So far. Okay, but before we do that, let's solve some exercises, this time forming a differential equation. Okay, let's form first a differential equation. So we will review first your derivative before integration, Michaela. Okay, so pabaya tong ano na to. Kasi later on naman, i-identify natin which method you will be using. For instance, no, here, I would like to create a differential equation, no, from this example that we have here. Okay. So here, y is equal to plus 1. So the constant is an arbitrary constant. Now, the purpose of which is to eliminate. So we need to eliminate the arbitrary constant. Okay, did you get it, Michaela? We need to eliminate the arbitrary constant by counting how many constants. No? One constant would mean one differentiation process. Two constants will mean 2, and etc. So for this case, we have I mean the types of ano, no? Kasi pwede naman dalawang C pero pareho lang. No, but if there are occasions that no, but basically we could eliminate using derivative. No? Let me sige. Okay, Michaela, can you get the derivative? What's the derivative of y prime? y prime tuloy, nasabi ko na. Derivative of y is y prime. Okay? Is equal to, can you give me the derivative of the right side of the equation?
That's
Derivative of
2x
2c.
2cx.
2cx. Alright. 2cx. Okay? And derivative of 1 is 1. 0 rather. So from here, still a c. However, we could solve for c on the given equation. Solve for c. Just give me the answer, Michaela. Given the equation, solve for c. What will be your c? Michaela, what is c? C is equal to
Medyo naman po kasi.
okay, solve for c. C is equal to y minus 1 all over x squared. Verify. Tama ba? Y minus 1 all over x squared.
Isunod po siya.
Okay? Then we will substitute afterwards, we will substitute this to the derivative. Substitute. So what will be your, so 2c so y minus 1 over x squared. Then we could just eliminated the c. So that's the times x here. Simplifying further, so that would cancel. So what would happen? So 2 times y minus 1 all over x. And from there, we could just multiply x to the other side of the equation. So the solution, in fact, the differential equation produced is xy prime is equal to 2 times y minus 1. Okay? That's how you eliminate constant. You could eliminate constant using derivative. Okay, Michaela, make sense?
So, saan po napunta po yung x squared po?
X squared. Saan napunta? Kinancel dun sa x. X and x squared. So, x na lang siya. Okay? Nagets? Okay, sige. This time you do this example. Okay, so given okay. So this time yung isang constant lang yan, c pa rin. Okay? Just the same, you get the derivative and then and you also solve for c from the original equation, substitute the c to the derivative equation and then rearrange and then you will get the answer. Okay? Please do the same. and just dictate me the answer afterwards. Or perhaps here, you could solve first for, sige, solve for C muna. What is C? Oh, kaya bang solvein yung C? Or wag mo na i-solve yung C? Pwede rin naman. What do you think, Micaela? So, kasi the next line of equation solution there, y prime, at least para mawala yung isang C, y prime is equal to 2c squared. Right? Y prime is equal to 2c squared.
Di ba yung si Sir constant po siya?
Constant, yes, constant.
Pero iba ba pa rin po yung 2?
Ay, teka, wait. C squared lang pala. Sorry. Nagkamali. C squared. C squared. Wala dapat
Okay.
to. C squared lang siya. Kasi yung x naman, derivative of x is 1. So, matitira dyan, c squared. Derivative of c is 0. So, parang dito, mababaliktad. Yung isa substitute mo, yung pangalawa sa una. Okay? Kindly, ayan. Magkakaroon ka kasi dyan ng square root, no? Okay? So, afterwards, sige, substitute natin. Ang purpose natin, ma-eliminate yung C. No? Either you use the differential equation or you use the original equation. Does not matter. No? So, from here, y is equal to c squared, which is equal to y prime or xy prime, and then plus c, plus square root of y prime. Because y prime is equal to c squared, therefore it follows that c is equal to square root of y. Yan, pwede natin siyang i-adjust. No? I think, we could expand this, or will you do, Micaela, here? So yung mga walang radical, ilagay mo sa kabila. So y minus xy prime is equal to square root of y prime. Okay? From there, we could square both sides of the equation. What's the square of the first, sige, you don't need to expand, no? The left side. So that would become y is equal to xy prime squared. And then that becomes y prime. Okay, so tanggal na yung radical. So, and that is also the answer already. Okay, so our purpose is to get rid of the constants. So actually, the given is a general equation. That's a general equation because there is a constant, arbitrary constant. We are to create a differential equation. So that's the purpose. Okay, some clarification. Micaela, can you do, sige, this time, ikaw na gumawa. Sige. So letter C example here. Let me see. xy is equal to x cubed minus c. Okay? Give me the value of c and your answer. And the derivative pala. So first, give me the value of c. Obviously, what's your c?
X cubed minus x1.
Alright, so we have here xy minus x cubed is equal to c. Correct.
Ano po siya? X cubed. Ano po ba? X cubed minus xy po.
You reverse already. Okay, sige. X cubed minus xy. Okay. X cubed minus xy is equal to c. Alright? Okay, give me the differential, the derivative in the derivative format. What's the derivative of xy? So we are looking here at implicit differentiation already. How will you differentiate xy? Is equal to the derivative of, or the differential, no? Kasi when we split the two, that becomes a differential. When the x and y combine, that's a derivative. Okay? Did you get the difference, Micaela? So this time we are dealing with individual variables, so it's a differential. Differential. Take note, x will still be your independent variable, y will still be dependent variable. Okay? So we're taking the derivative or the differential of both sides of the equation. What will be the differential of the okay, what's the differential of xy, Micaela? Okay? So, using your product formula, right? So, that becomes x or y plus x y prime. Y derivative x plus x derivative y. Y derivative x is 1. So y remains. X derivative or differential of y is y prime. Okay? Then from here, you have 3x squared okay. So it's good thing when you get the derivative, no constant anymore. So you don't need to substitute. Pala, Micaela. Oh, I realized that the constant had been eradicated upon differentiation. So you don't need to substitute the value of c. Okay? So di ko rin napansin to kanina. So this in itself is already an answer because there is no constant anymore. Okay, make sense? Micaela?
Yes po.
Alright.
Medyo ganito lang po dun sa, kalimutan niyo po yung sa
So product formula.
implicit.
Yung product formula. Oo. So ganun siya i-apply, no? Yung derivative of y derivative x, x derivative y. So y derivative x is y, x derivative y is x prime, xy prime. Right? So that's how we do it. Anyway, another example. This time I'll be giving you a more interesting. This time there are 3 constants. Y is equal to c sub 1 plus c sub 2 x plus c sub 3 x squared. Solve for the differential equation. Now, for us to solve this, before substituting c, sometimes c is not anymore required. That's why we first solve using the differentials. Since there are three constants, we need to differentiate it 3 times. So we need to solve for the first differential, the second differential, and the third differential. Right? So for the first differential, okay, y prime. What will be the y prime, Micaela? Derivative of the given equation.
2x plus 1.
Okay, 2, that becomes C. C sub 2 na lang? Tama? C sub 2? C sub 2 plus 2. C sub 3 x. Tama ba? Derivative of C sub 2x is C sub 2.
Yes po.
Alright. So, still have 2 more derivatives. How about y double prime?
Person.
Okay. Nangyari doon. Okay, wala pala ako sa ano. Y double prime is equal to 2 C sub 3.
Yes, sir.
Alright? And then, x. Isa na lang. Y triple prime. What would be the answer?
Zero po.
The answer is 0. 0. Okay? Because 2 and c sub 3 are constants, derivative of constant 0. So, here, wala nang constant. Therefore, that's already a solution. That's already an answer. Okay? Make sense, Michaela? Okay, sige. Another. E. Ito, huli na to. At least para masanay ka rin. Kasi minsan, bihira lumabas sa exams to eh. Yung may mga arbitrary constant you need to eliminate. No? For the case of letter E, there are 3 arbitrary constant you need to perform up to third derivative or third differential. Okay, for this one, there are only 2 constants, arbitrary constants. No? So, y is equal to c sub 1, but this time, may sign of x ka pa. Sign of x. That will make it difficult, no? Now, plus, you have c sub 2 cosine. X, okay? Okay, tell me the first derivative. Or y prime.
Cosine x sub 1. Cosine x minus c sub 2 sin x.
Minus, no? Okay, minus c sub 2 sin x, okay? Okay, next, y double prime.
Negative c1 sub 1 sin x.
Okay,
Minus c sub 2 sin x.
okay. So from here, what would happen? Which is more similar, y and y double prime, right? However, separated by a negative sign, right?
Yes, sir.
So if that would be the case, so y double prime okay, y double prime is equal to negative of c sub 1 sin x plus c sub 2 cosine x. And basically, that is equal to y. So therefore, this is equal to negative y. And to put it
Negative
properly,
y.
yes, to put it properly, you could equate this to 0. So y double prime double prime plus y is equal to 0. Okay? So that's the differential equation of the given. Okay, make sense, Micaela? Actually, wala pang methods dito. Parang ito, yung reverse operation ng ating gagawin. Because basically, we'll have integration on the methods. This one is a preparation. Given a general equation with arbitrary constants, we need to eliminate the arbitrary constant by differentiation. So the number of differentiation will depend on the number of arbitrary constant. If there are 3 distinct arbitrary constant, you need to have triple derivative or differentials. No? For this case, for this problem, we have 2 arbitrary constant. Therefore, we need to perform 2 derivatives. No? or second degree derivative. Okay, or y double prime. Okay. Now let's move on here. This time we are now looking into the variable separable. Differential equation wherein we could just easily separate the variables from the respective derivatives or differential and perform the indicated integration. No? So here's an example. For instance, you have y dy minus 4x dx. In fact, this is already separated. No? X is with dy, y is with dy, and x is with dx. They're already separated. You don't need to separate them. So you just put it on the other side of the equation, right? So just put it on the other side of the equation. Bakit siya may ganun? Ayaw niya magkadikit. Okay? So just put it on the other side of the equation. So, or this would become y dy is equal to 4x dx. Okay, make sense, Micaela? Make sense?
Yes po.
Okay, afterwards, after you separate it in both left and right side of the equation, you perform the indicated integration. You could now integrate an indefinite integral y dy is equal to integral of 4x dx. Okay? So that's how you do it. Or, what's the answer? Integral of y with respect to y. What's the answer?
Plus 1 over 2.
That is y squared. Y squared. Y squared over 2. Right? Over 2 is equal to is equal to, or I will put it for 4x squared over 2 c. Then we need to get rid of the, we need to get rid of that fraction. Okay? Okay, multiplying both sides by 2. So the arbitrary constant will absorb the multiplication of 2. So what would happen there is y squared would be equal to 4x squared c. Na-absorb na ng 2 si c. 2 times c is still a constant. Okay, that's the answer, Micaela. Okay, make sense? So this variable separable. Obviously, it's a variable separable. No, kasi nakaano na siya eh. Okay, please do this. Right, so we have here so give me the, okay, rearrange first. Give me the rearrange equation, Micaela. CR. Okay. Sige, noted. Noted. Just let me know if you're here.
Hindi po.
Okay, sige. Okay na. Sige. You tell me your, uh, you rearrange. Please tell me the arrangement. That becomes y squared dy is equal to
3x raised to the 5th dx po.
okay, sige. Okay, perform the integration, both sides. The integral of y squared is equal to integral of 3x to the 5th dx. Okay, tell me your answer.
Ano po? Yung integral po ba?
Yes, perform the integration.
Y cube over 3 equals 3x raised to 6 over 6 plus
Okay, so that will become y cube over 3 is equal to plus 3x to the 6 over 6. Okay, plus c. Don't forget the c. Or further simplify, so there are cancellations. Cancellations here. Or
2y cube equals 3x raised to 6.
this is becoming 2x to the 6, right? No, wait. Sorry. X to the 6 over 2, right? Plus c, right? So, give me the final answer. Eradicating the fraction.
Ano po sir? 2y cube equals 3x raised to 6 plus c.
Okay, correct. 2x cube, 2y cube. Okay, wait. 2y cube is equal to 3x to the 6 plus c. Alright, correct. Alright, let's move on now to the next type, which is homogeneous equation. So, homogeneous, no? Let me try to explain. Sometimes it's not separated. You cannot separate the variable, no? That's a dilemma. No? So we need to look into the next example, next methodology, which is homogeneous equation. So there is what we call, so normally we apply homogeneous if there are functions of x and y combined. Okay? It's said to be homogeneous of degree, and if f, no, so there is a clarification here. It's homogeneous in nature if the f of delta, wait, I need to switch on the equation. Supposedly, it is a homogeneous equation. We need to test that if f lambda, lambda, lambda. Okay, wait for a while guys. Ay, dali lang. Ayan, pumasok. Gumagawa kanina. Okay, so that would be the case if we have this specific function, constant, lambda, x, and lambda y could be extracted out. So it's equal to lambda f of there's an n function here, no? X and y. Okay. So meaning we need to transform. On the other hand, we need to transform the equation first. Okay, we need to transform. And what we'll be creating here, okay, what we will be creating from this is an equation that is homogeneous. Meaning we'll make it of the same degree. Dapat magiging the same degree siya. Mamaya, papaliwanag ko yan through an example here. M of xy dx plus n xy dy is equal to 0. So magkakaroon ka ng ganyang klaseng equation, and we could make use of manipulations. So yung m and n are already of the same degree, homogeneous the same degree, and that could be verified using this formula if they are really homogeneous or not. Could verify that y is equal to bx and that dy is equal to bdx plus xdb. No? Sounds familiar, no? Yan, bdx will transform a homogeneous equation into separable equation in variables x and b. So magiging, in a way, magiging variable separable siya. Okay, let's have an example here. Okay, an example would be this one. Okay, this is an example. We will test the homogeneity of this equation because somewhat it's hard to for us to have variable separable on this case. It's very hard. No, mahirap. No, kasi but we could test its homogeneity. No? Let us test first the homogeneity by substituting so we will have some transformation here such that your y where it's coming from this case, no, we'll just copy. I'll just copy here. This one, this will be your test of homogeneity. Okay, so from that, it will yield to a particular equation if you will substitute, no. So what will you substitute here is actually your b. Now your y and your dy you will substitute. Okay, you will substitute to the original equation. So what will you have here? So what you will have is 2x y is equal to bx, and then your dy is equal to b dx plus x dv, right? So that would be the case here, and of course that would be equal now to the next x squared minus y squared. So you'll substitute the y here. So in the form of all right, let me clarify here. So we have b squared x squared kasi y is equal to bx, no? That's your substitution. Lalo ba naging komplikado? Now, from here, we could perform variable separable. Are you still with me, Micaela? So medyo mahirap lang homogeneous sa una, no? But we need to look into this as second option aside from variable separable, right? So if it's not separable, you may use homogeneous equation. And one way, you put this equation, you put this, and at dapat magkaroon na siya ng separability. Separability. Now, for this case, let me see if we will have some separability here. Okay. So medyo ano lang to, kailangan talaga ng hard work dito sa methodology na to. So for this first, can you simplify, Micaela, the left side? Can you simplify the left side, Micaela? Just dictate to me the answer.
Bx squared
B squared. Right? Bx plus
bx cubed.
2x cube. X cube, no? X cube b. X cube b.
Yes.
db. Excuse. Excuse me. Okay. For the right side, we could already factor out x squared dx. Tama? Excuse me. Can we factor in the right side? X squared, x squared dx. Tama, no? X squared.
X squared dx. And then it's this.
Ayan. So we successfully separate x and b here. Ano naman yung sa kaliwa? So what we could be factor out here? Kaya medyo mahirap to homogeneous, no? So ano yung pwede nating i-ano dito? So for dx, balikan ko to, Micaela. Medyo nalito rin ako. Balikan ko, wait, ano na natin to. To maximize our time. Okay, sige, babalikan ko to. Medyo nalito rin ako dun. Dapat magkakaroon na siya ng B na lang siya. Yan, magiging variable separable siya. Actually, parang may magka-cancel dito sa una pa lang dito. Nung in-expand mo siya, that pala hindi natin pinactor out to. No, kasi meron siyang common doon sa kabila, no? I think we could maintain that. May common factor ba to? X cube. X cube, no? Pwede palang ano. So, pwede siyang mag-cancel, no? X cube. So, kung ganon, tama. Pwedeng mag-X cube, no? So, extract natin yung X cube. So, magka-cancel siya. X cube. 2 X cube B. Kaya lang, walang makaka-cancel dun sa kabila, no? Sige, X lang muna. Try natin X. X2. Okay, 2 dx. xb na lang, bb. Tanggal yun. Extract to. Pwede na natin pagsamahin yung 2b squared dx, no, dito. Pagtanggal to, natanggal yung x squared. So magiging ano siya, variable separable. Tama. Hopefully, no. Sige, nakikita ko, nakakinita na ako ng ng pag-asa dito. So nung natanggal yung x squared, cancel na yan. So bubukas to. 2b squared dx plus 2xb bb. So matitira na lang dx na lang, no? So ang mangyayari niyan, pagsasamahin ko. Tama. dx, yan. Alright. Sige, nakakita na ako ng ano. Okay, we will combine that here. So magiging 2xb bb is equal now to, so papasok siya sa kabila, Micaela, yung 1 minus b squared. May 2b squared ka sa kabila, magiging 1 minus 3b squared dx. Ayan na, variable separable na. Did you get it, Micaela? Nagkamali lang ng manipulation kanina. Dito, pwede na separable. So, mananatili yung b, ibababa yung yung x lang ang bababa dun sa kabila. Tapos yung 1 minus 3b squared. Yun yung dito sa left side. So, what would happen is 2b bb. Fraction muna natin. 2b bb all over 1 minus 3b squared. Okay? Is equal to dx over x. Gets ba, Micaela? Okay, can you copy?
Yes po.
All right. So integrate both sides. Can you integrate? Integrate both sides. Okay. Okay. So that's the ano. Okay. du over u over du, no? U du over u rather. What's the derivative of u here on the left side, Michaela? What's the derivative of what's du on the left side? Yung du lang kasi du over u yan. What's the du? Yung u is equal to 1 minus 3b squared. What's the du? Expected du? Para maging ln of u to.
6 by po ba?
Okay, 6u. 6b. O kaya lang, meron ka lang to dun eh. So, magkakaroon ka ng neutralizing factor na 1/3. Tama? 1/3. At negative. Kasi negative 6, di ba? Michaela? So, negative 1/3. Huh? Michaela? Negative 1/3. Oh, ln. Magiging ln yan. Ln of 1 minus 3b squared. No? du over u. Integral of du over u, Michaela. Ln u plus c. Okay? Gets ba? Okay, nagets ba, Michaela? Du over u. Alright? So, derivative of u, negative 6u, negative 6b. Ano lang yun nandun? 2 lang. So, kailangan mo ng neutralizing factor na negative 1/3. Right? How about the right side naman? What's the right side? Right side of the equation. Right side. Right side. Right side simply is ln x plus, don't forget the constant, ln c. I-consider din natin na yun yung kamukha ni ln c. Right? So, actually marami pang ano dito eh. So, pero enough ng answer yan. That's an enough answer. So, medyo mahaba yung homogeneous, no? Medyo siya mahaba. No, pero sige, tuloy ko na rin to. Okay, from here, Pwede natin tanggalin yung fraction, no? Pwede natin siyang tanggalin. No? Negative, matitira lang yung cons, i-equate natin sa 0. So what you will have here, multiplying both sides by negative 3, no? Negative 3. So magiging positive ln of 1 minus 3b squared. Okay? So yung negative ni ln of x, itatranspose ko sa kabila, magiging positive ln of x. Alright? Okay, Micaela? So yung negative, kasi minultiply mo na negative, supposedly negative ano siya, magiging negative 3 ln of x. So kaya lang, i-transpose ko sa kabila, magiging positive. And then yung pwede natin siyang i-minus din. So magiging ln of c prime. Kasi dapat 3 ln of c siya eh. So just to differentiate 3 ln of c with ln of c, I will put here ln of c prime. Okay, ln of c prime. It's equal to 0.
Ln of c din.
Pinorma lang natin na kamukha. Constant pa rin siya. Pinorma lang natin na kamukha ng variable. Actually, pwedeng C, pero magkakaproblema kapag minanipulate mo na hindi siya nakalon. So, tinagma lang natin nakatulad ng mga variables. Pero ln of C, it's constant. So, no problem. No problem sa kanya. Ang layunin niyan, that's a purpose, it will be look like the variable. Okay? So, ganun yung ano natin. Now, from here, so pwede na natin siyang ayan, so pwede natin siyang erase sa E. No? I-erase natin siya sa E. Okay? So paano natin i-erase sa E yan? Kasi puro ln to, pwede na natin erase sa E. Yan. So naka-erase na siya. So lahat ng ito, ma-erase natin sa E. Right? So from that case, is equal to E raised to 0. What's E raised to 0? Kayla, what's E raised to 0? It's 1. Okay. So from here, pwede natin power rule o law of exponent, pwede natin siya pag i-dissect, no? E raised to ln of 1 minus 3b squared. Okay, times E, laws of exponent to. Gets ba, Micaela? Laws of exponent. 3 ln of x, okay, times E raised to ln of c prime is equal to 1. Okay. What is e raised to ln? Kayla, what's e raised to ln? What is e raised to ln of something? E raised to ln of u. What's the answer? Is u. Equal to u lang. So, ito, so 1 minus 3b squared na lang. Magka-cancel lang yung isa kalon. Magka-cancel lang yan. Times. Ito naman, kung i-convert natin tong 3, gagawin mong ln of x cubed. Okay? What is e raised to ln x cubed? Micaela?
Sir, paano po siya naging x cube, sir?
Those are opposite process eh. X cube. Binalik mo. Laws of logarithm, Micaela. Binalik ko lang. Ln of x cube, 3 ln x. Di ba? Laws of logarithm yun. Para makancel yung e sa kalon. So magiging x cube na lang. Dito naman, okay, c. Magiging c na lang to. C equal to 1. Malapit na tayo. Ngayon, ipapasok natin lahat ng variable dun sa... So this would become c. C of x cube. Papasok natin siya doon. Multiplied by 1 minus 3 b squared. Equal to 1. Now, since b is equal to what? B is equal to y over x here, isa-substitute natin. Babalik natin, kailangan maging x and y lang siya. Your b is equal to y over x. Okay, substitute. Okay, substitute.
Sir, saan po ulit ka namin, sir?
Hindi ko nakuha yan. Ano sabi mo? Kasi y is equal to bx eh. Y is equal to bx, therefore b is equal to y over x. Yung kanina substitution natin, ito yun, no? Ayun, no? Y is equal to bx. Babalik ka dyan. Therefore, b is equal to y over x. Okay, substitute natin dito. Ito. So, anong lalabas dyan? So, you have c x cubed of 1 minus 3 multiplied by y over x squared. Okay, is equal to 1. Simplifying further. C. multiply ko na pala, no? Sige, i-x cube ko na rin dito. Oh. So, magka-cancel, no? X squared. Okay, distribute ko na rin yung x cube. See? This becomes minus 3x y squared is equal to 1. Okay? So that's the answer. Haba, no? So, homogeneous yan. Homogeneous. Ito, pampa-bonus ko sa Michaela. You could derive this. Another variable separable. Variable separable. Ito. Variable separable siya. No? Okay? So, what will be the variable separable expression, Michaela? What will be the variable separable expression?
Basta substitute lang po yung sa una ay binigay.
Oh, i-transpose mo. Group all the y's to the left, group all the x to the right. Ganun siya. Oh, dy over
Salamat.
is equal to dx all over. Ayan, nandiyan na. Sine squared x. Okay, please perform the integration of both sides. Integration. Or perhaps, pwede mo munang i-reciprocate. No? Using your trigonometric identities. So what is 1 over cosine? What's that? What's 1 over cosine squared?
Second.
secant squared. Ayan. So, integrate mo yun. Yan na lang integrate mo. Oh. So, obviously, for sine squared, ano naman siya, reciprocal. That is
Second.
cosecant, correct. Alright, cosecant. And what's the answer? Integral of secant. Integral of secant.
Tangent.
Tangent y equal to integral of cosecant squared.
Negative 2, negative 2 over 2, tangent x, negative tangent x.
Negative cotangent x. So review your integral of integration of trigonometric functions there. Plus C. Okay, so that's the answer. Mahaba talaga yung homogeneous, no? Sige, we have few minutes. Perhaps I would look into the order one. Okay, for a while lang. Okay, I'll look for another variable separable. Okay, I think this will be fine with you. Uli na to, last item na to. Okay. Okay, basically they're variable separable. Please rearrange, Michaela. dy on the left, dx on the right. Okay, what's the, you separate the variables. No
dy
audio.
over 1 plus
Ayan.
y squared.
So dy all over 1 plus y squared is equal to,
X over plus x squared.
okay, so please integrate. What will be the integral? Okay, what will be the integral of dy all over 1 plus y squared, which is equal to the integral of dx over 1 plus x squared. Okay? Okay, if you will recall your arc tangent, all right? So seemingly, that's an arc tangent. Derivative of arc tangent x is equal to 1 over 1 plus x squared. Therefore, integral of 1 plus 1 all over 1 plus x squared is arc tangent of x. Okay, make sense, Michaela? So what would be the answer here?
Arctangent 1 equals arctangent x.
All right. Arctangent x is equal to arctangent y plus c. Actually, plus arctangent c din. So, plus c. Yung plus na yan, kukopyahin din natin. No? All right. So here, we could further simplify this by solving for y. Y therefore, y is equal to, so kung, so if you would like to solve tangent y, arctangent y, if we will transpose that to the other side, what will be the answer? I'm sorry, baliktad pala ako. This is supposedly y, this is supposedly x. Right? So if I would like to solve for tangent or y, so if I will transpose arctangent from left to right, what will be the operation? That will be tangent. Tama mo, Micaela? Naging tangent sa kabila yun. Arctangent sa kaliwa, tangent sa kanan. Okay? Tangent of what? Of course, kung ano yung nakapaloob sa right side of the equation, which is arctangent of yan, of negative x plus right. So can you solve, simplify? Michaela, can you do this? Recalling your tangent x plus y. Trigo identity. Recall. Tangent x plus y. Ano nga ulito, Michaela? Can you recall? Tangent x plus y is equal to
Tangent x plus tangent y over
tangent x.
tangent x tangent y.
Okay, correct. This is 1 minus tangent x tangent y. Now, substitute natin dito. Substitute natin. Y is equal now tangent of arctangent of x. What's the answer? Tangent of arctangent of x. What's the answer, Bella? Bella, tangent of arctangent of x. Oh, what's the answer? Tangent of arctangent of x. What's the answer? X, di ba? X. Oh, therefore, tangent of arctangent of C, obviously it's C, all over 1 minus arctangent of x. Tangent of arctangent of x is x and C also. So therefore, this is minus C x. Right? So that's the answer. Okay? So yan, you could review this, Michaela, since I uploaded the entire material for differential. But perhaps I will, siguro magpo-focus ako sa variable, separable, saka sa homogeneous lang. Okay? So I will not touch any other methodologies. And plus, yung nauna, yung elimination of arbitrary constants from general equation to differential equation. So those three. Elimination of arbitrary constants, and then variable, separable, and homogeneous equation. So those are the coverage. Perhaps I will just, and plus the multiple integration, I will have problems in double and triple integration as well. So that would be the coverage of your take-home exam. Okay, just save this file for your review. So this had been the combination of 143 and 163. So their thoughts, Michaela, before we close? So that your preparation, I know you need to eat your lunch prior to your schedule this afternoon. So next week, we'll just meet by 9 a.m. Okay? So I hope that would be, Lord willing, that we will continue for next week. Okay? Michaela, other thoughts before we close?
Yes, sir. Thank you.
Okay, let's pray. Father in heaven, we thank you for this day. Thank you for the opportunity where we could continue in a double broadcast of 143 and 163. I pray for your guidance. This semester had been a blessing to us, even the students. I pray that that they may learn continuously, and that this will be beneficial on their aspiration to become teachers of their respective ministries and schools. Oh Lord, so help them and continually guide them. And as they prepare for their final examination with other courses, I pray also that your grace and guidance be upon us. We thank you, Lord. We honor you as we continue today. May your mercies be upon us as well. This is our prayer in Christ's name. Amen. Okay, thank you, Amika Ella. See you next week. And the rest of the math majors, God bless you. Bye.